Anybody know if it's not a scalar or a vector? Anyone else know another mathematical construct? Beyond the scope of this course, they're called tensors. Just put that sort of aside there. Tensor calculus gets complicated real fast. But if you get into general relativity and you start dealing with the curve of space and time, tensors pops in. All right, so there's certain words that are automatically vectors, certain words that are automatically scalars. So if ever you're asked for position, position is a vector quantity. The symbol for position, X, Y, Z, R, S. These are the most common letters that I'll be using for position. R typically is for radial if you're dealing with a position based upon some central point. R typically is used at that point, but it doesn't have to be. S comes from the Latin stadia, which was basically the ancient Roman mile. Some books will use X, Y, and Z for specifically the brainwashed math, X, Y, Z, but X is whatever direction I really say. All right, and position is where an object is. With respect to the origin. Now, choice of origin, oftentimes there's a convenient place to put the origin, but the origin really is anywhere you want it to be. So if we go for the classic math, I hat, let's make it down J hat. Why not? What is the position of that spot? Assuming these are increments of 1.
I had negative 2j.
How would you write that? I just want to make sure that it's correct in your head.
Okay.
So you said 3I hat, negative 3j hat?
Minus 3j.
Okay. Not 3.
Minus 2, sorry.
Yeah. You might have said 2 the first time. 3I hat minus 2j hat. Or plus negative 2j hat, whichever is the way your brain is working at that moment. All right. Another vector word. As soon as you see it, you should be thinking vector, direction matters, displacement. And the symbol for displacement is pretty much that, except with the change in front of it. So it's change in X, change in Y, etc. Some textbooks will not differentiate between the two, and I'll at some point potentially get into how they can get away with it. But it has basically 2 definitions. Where an object is with respect to the starting point, or change in position. And these are interchangeable mostly because if I move from here to here, that's my change in position. This is my initial position. That is my final position. So my displacement is my change in position, which is that right there, or it is where I am relative to where I started. So if I die in the bed where I was born, my displacement for my life would be 0. I could actually make the argument that my left eye has never moved. The center of my left eye has been the same spot the entire time. It's the world that's moved around me. All right. Questions here? All right, there is a scalar analog for displacement, and that is known as distance. So if I ask for the distance traveled, I'm looking for a scalar. So let's just do a quick example here. Start here, I go 3 meters to the right, I go 4 meters up. What is the distance I traveled?
7 meters.
Yep. And the symbol delta x or delta y or whatever letter I happen to be using, but there's just no vector symbol over it. So that's the distance I traveled. What is my displacement?
5 meters.
So far, so good. What's missing? Hint, it's a vector.
Just I hat.
How you don't want to define I hat?
That's the direction I want to define it in.
So you're just gonna make, that's I hat right there?
Yeah.
Yeah, that's legitimate. Let's do it slightly differently though. I'm surprised at the number of students who don't think of doing things like that. And there are times in which that is really convenient. However, suppose we want to keep with the brainwashed math, and so positive, positive.
Let's see, break it up to 3 meters I hat plus 4 meters J hat.
Yep, there you go. So my displacement is 3 meters I hat plus 4 meters J hat. This is referred to as rectangular notation. And that is the word rectangular notation, despite the way it might look. But if I wanted to do it in terms of distance, or, the magnitude of the displacement and the angle, what angle would that be?
45 degrees, assuming.
For 45, those would be the same number.
It's like
Oh, yeah,
38, yeah, 38 degrees. About.
I think you're thinking of 37, but it's not.
would be 30. Or,
No, 37 is, 37 would make sense. You would not lose as many points for 37 degrees as you would for 30 or 45.
You looking for decimals?
No, I'm fine with rounding it off to the nearest degree. It's something, if you're thinking it's something deep and tricky, it's not, it's your mind's just in a red.
It's not 90.
Not 90. I'm looking for, all right, so that is my displacement right there. That's my displacement. I'm looking for that angle.
It's not 60, is it?
No, it is not.
Would it be 36.86?
No, I assume that's what Michael was going for when he said 38.
27.5.
Okay. I think you're gonna go, oh, of course, it's revealed. All right, so we'll laterally call this theta. What would be the tangent of theta?
1/3.
So theta is the arctan of 4/3. The angle is
$52.43.
I'm gonna round it off, 53 degrees. That's the 37-degree angle out there. Short side. The small angle is opposite the small side. Middle side, middle angle. All right, so 53 degrees-ish. This is polar notation. If I don't specify, either one. Sometimes the question is, what's the magnitude of the resultant? Resultant just being the key word for sum. What is the direction? Now, for the most part, if you're doing I hat, J hat, you have to define those directions. One place where I'm just accepting that you don't have to define it is for angle 0 degrees is going to be to the right, 90 degrees, 180 degrees, 270, 360, and so on. Negative angles going the other direction, or 0, pi over 2, pi, 3 pi over 2, 0, and then negatives going the other way. So if I ask for a direction in terms of angle, just assume that to the right is 0 degrees. Now, if you don't want that to be 0 degrees, then define it. On a problem like this, if you said, I just want to make that 0 degrees right there, I would ask, what direction is that? There are only so many shortcuts you can take. All right, so I start here in Columbia, South Carolina. I'm going to assume Winston-Salem is due north. That's about 200 miles. I go from Columbia, of course, I'm going to take some back roads just for some scenery. And my odometer says 500 miles. I've driven 500 miles. What is the distance traveled?
500 miles.
What is my displacement?
200 miles.
Keep going.
200 miles?
90 degrees.
Oh, okay. I was expecting something different there, but yeah, 90 degrees works. Or north, in this particular case. We do have one other option here. If we're dealing with a one-dimensional problem, I could define that as I hat, or J hat, whichever one I feel like, or K hat. But if ultimately I'm just dealing with one dimension there, I can just get away with a plus or a minus. So I could, in this case, just say, well, let's just make up positive. And so my displacement is 200 miles. Put the plus in this to emphasize it. And that's going to become critical at some point. Now, if you want to use I hat and you just want to stay away from just saying, oh, that's the positive direction, that's fine. If you're in a two-dimensional problem, you cannot get away with just the plus. Questions here? All right, let's take a 5-minute break or so, and then we'll reconvene, refreshed and raring to go. All right, so I'm going to take you through an exercise here called plus minus 0. And it's a one-dimensional problem, just moving back and forth. And I'm going to establish this as my origin. And for the sake of this, I'm going to establish this as my starting point. That's what SP for starting point. So, oh, I need to define what the positive direction is. And based on habit, I'm just gonna make to the right positive. Now, there might be a little bit of a parallax here, so right here, I'm at the starting point, even if I look like I'm behind it for you and in front of it for you. All right, so right now, my position, positive, negative, 0.
0,
Why?
because you're at the origin.
My origin's over there.
Oh, I thought you,
Starting point, origin.
okay. You're positive.
Sound like there was a question mark there. It's all, it looked like you were nodding yes. You support that?
Yeah.
Okay, positive. All right. My displacement?
Zero.
Yep, I'm at my starting point. My displacement now?
Negative.
Why?
You went back.
I went back.
Yeah, you went back from the starting point.
Where am I relative to my starting point?
Positive.
I'm on the positive side.
Oh.
Positive displacement. And my position?
Positive.
Usually without the question mark, but yes. My position?
Positive.
Negative.
Why?
You're away from the starting point on the left side.
Position deals with origin.
Still positive.
Positive position and displacement?
Negative.
Yep. All right. And then displacement,
Negative.
position.
Negative.
All right. This is how the game is played. It's going to get more difficult. All right. The next vector quantity that we're going to deal with here is velocity. You see the word velocity, it's automatically think, ah, that's a vector. The symbol used for velocity, the clever way they come up with the stuff, it is a V with a vector symbol over it. It is how fast and in what direction an object moves. Or it's the change in the position with respect to time. It's supposed to be a vector symbol with the X there. And so the first bit of calculus thrown into the problem. This is the first derivative of position with respect to time. However, you could actually write another one of delta x over delta t. Obviously, if I'm doing a derivative there, I'm dealing with an infinitesimally small change in time, but if I'm doing a delta there, I'm dealing with a larger chunk, a macroscopic chunk of time. And so the difference between these two is this is instantaneous velocity. And this is average. Now, if I ask what is the velocity of an object, if I don't put any qualifier in front of it, instantaneous is the default. So this is my default value right here. So if I want the average velocity, I need to actually say average. Displacement, we can also look at it at 2 different points. We can talk about the displacement in terms of the instantaneous, or overall. And the default is overall. So in this exercise here where I said, what is my displacement? I was talking about from my starting point, not from where I was a moment earlier. So for instance, right now, my displacement based on that starting point is negative. My displacement overall is still negative, but my instantaneous is positive because I'm moving in that direction, because I am on the positive side of where I just was. So in terms of the language, the default is overall for displacement and instantaneous for velocity. questions there? The scalar analog of that. Anyone?
Speed.
Absolutely. If you get pulled over for a speeding ticket because you were speeding, I don't think anywhere in there does it say which direction you're moving. You do not get a ticket for velocity, you get a ticket for speed. The symbol for speed is a V without the vector symbol. I guess to make it complete, it's delta x, and so on, but without the vector symbol. All right, so let's run through a little exercise here. So let's go back to our Columbia and Winston-Salem to 100 miles. And we'll just make up our north positive. So again, I have my trip where I just go straight there. Well, I end up there relative to where I started, and then I've got the, the scenic route where I went 500 miles. And let's say it takes 10 hours. 10-hour trip. What is my average speed?
20 miles an hour.
Nope.
50,
Sorry?
50 miles an hour?
Yeah, 50 miles per hour. Velocity is change in position over change in time, or displacement over time. Speed would be distance over time. And so the distance traveled was 500 miles, so my average speed is distance divided by time, which is 500 miles over 10 hours.